And this is the graph of the constant speed in the negative direction. Our y-intercept here is negative 1.75 inches per second, which means that at time equals to 0, that's where the fan cart was. Our slope is almost 0, which means that it is accelerating at a rate of 0, constant velocity. And our equation is 0 times t minus 1.75 inches per second.
So at 0 seconds, this car was approximately at 0.4 inches per second. The slope is 4.5 inches per second squared, which is its rate of acceleration, and the equation for this is 4.5 times t plus 0.4 inches per second. So for this car, at 0 seconds, the car is moving negative 4.3 inches per second, and the slope is 5.6 inches per second squared, and that's the rate of acceleration of the car. And the equation for this is 5.6 inches per second squared times t plus negative 4.3
inches per second.
So this graph is the car slowing down in the negative direction, and we linearized it by making it 1 over time. And for this, at 0 seconds, the car is at negative 2 inches per second, and the slope is 0.3 inches per second, and the equation is, sorry, I meant to say 0.3 inches times second per second, and the equation is 0.3 inches times second per second times t minus 2 inches per second.
So now we're slowing down in the positive direction, and we linearize this graph by squaring velocity. And the equation for this graph is going to be 5.4 inches per second squared divided by seconds times t minus 0.9 inches per second squared, which means that so the y-intercept is negative 0.9 inches per second squared, which means that at time t equals to 0, that was the velocity of the fan cart, and our slope is 5.4 inches per second squared per second, which means that is our rate of acceleration.